Good morning, Shishir sir. Good morning, everyone. This is day 9 of our webinar series on AI and data science. And on behalf of C-DAC Patna, we are really privileged to have on board with us retired Commodore Dr. Shishir sir from KPIT to little bit tell about his profile, and then we can start with today's session on applications of AI in mobility. Sir is PhD from IIT Bombay under the guidance of Professor Vikram B. M. Gadre, and the topic was parameter estimation of chirp signals. He has done his MTech in communications from IIT Kanpur, BTech from electrical engineering from Naval College of Engineering, Pune, India, Pune, and then BSc also did his BSc from Military of Science, NDA, Pune. He has 25 years, served 25 years in Indian Navy, DRDO, and industry as an R&D client induction and faculty. He has served as associate professor at VIT Pune and Wipro Technologies for a year and so. He has been project lead and currently is also practice director autonomous driving at KPIT Technologies, which is domain ranging from digital signals, from digital communications, random process detections, estimation theory, working on advanced driver assistance systems, connected autonomous vehicles. And why I find this topic and the talk very relevant in this scenario is slowly although we are also in talks of use of AI and applications of AI in each domain. In previous session, we worked on AI for healthcare, and equally relevant, I find the application of AI in mobility. So I strongly feel this would be a great session for all the participants to learn from. Over to you, sir. Thank you very much.
Yeah. Thank you, sir. And is my voice audible?
Yes, sir. Very clear.
Okay. So thank you, everybody. And a special thanks to Mr. Santranjan, who gave me this opportunity to interact with the audience. And of course, to the director of C-DAC Patna. It's really an honor. 1 second, please.
It is coming.
Right. Thank you. So I have with me my team member Trilochan Sharma, who will be helping me in giving this presentation. And the topic was very nice and interesting, which was given to us. So there are 3 topics, if I can, 3 subtopics within the topics, if I can say. So there is intelligence, but we are not talking about human intelligence. We are talking about artificial intelligence, and then there is mobility. Right. So let's break down the topic and let's go ahead and then let's talk about it one by one. Right. So, yes, as I mentioned, my acknowledgements to Mr. Santranjan at KPIT Technologies. So the flow of presentation, as I just mentioned, would be as follows. We first talk about artificial intelligence, machine learning, and deep learning, and what are their relationship. As Mr. Saket said, possibly the audience is already aware of that, but we can have a quick recap on that. What are automotive systems, the evolution of automobiles, latest advancements, what autonomous driving is all about, what do you mean by the levels of autonomous driving, what are the 5 pillars of autonomous driving. Supposing if within the audience here, 10 people get together and they say, okay, let's make an autonomous driving car, right? Then what should you do? Or what do you do as a driver of a car? So everybody knows that, but I'm just kind of breaking it down and presenting in front of you. Then the last part about the applications of AI. Right. The last part about hybrid vehicles and electric vehicles and the applications of AI in that field will be handled by Trilochan. So I'll pause here for a minute and I would allow the audience to soak in the flow of the presentation. Right. My acknowledgements, of course, to Wikipedia and so many other websites, and of course, peppered with my own experience, which I have tried to present in front of the audience. Now, what is intelligence? Have you ever thought about it? Okay, so a very basic question to ask. So we all, understand that intelligence is basically a capacity. A capacity for what? For logic, for understanding, self-awareness, blah, 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 all those things which are there. Key important point, emotional knowledge. Okay, we'll talk about it when we go ahead. But we all agree that yes, a capacity for all those things on the left-hand side is a component of intelligence. and then the ability to perceive and then infer information. There's a lot of data, but how do you perceive the important data in amongst the hordes of data which is there with you, and then you infer information. Information is that part of the data which is important for you. To give an example, of course, information is closely related to probability theory, but you may have data that the sun rises in the east, the moon rises in the east, the planets rise in the east. There's a lot of data, but is there any information in that? Right? Think about it. Then action. So you have the capacity for blah blah blah, ability to do this, and then action. So what action means? It means retain the inferred information. So you had information, you made some inferences from that information, and you retained it. That is also important. And then, as if you made an essence of the entire information, and then you have applied it. And again, the keyword towards adaptive behavior. A robot can do repetitive tasks very clearly, but can a robot adapt itself to the new situation? Can the robot understand that, hey, I have been exposed to these experiences in my life, and now this is this situation in front of me. What are the similarities and what are the differences? As a soldier, I'm trained to kill the enemy, but yes, I'm going for a covert mission, and now there is a kid who's standing in front of me, and there is a terrorist who's standing in front of me. Should I shoot both of them, or should I just shoot the terrorist? Right? And also to be successful within an environment or a context. So all these things, ladies and gentlemen, comprise what is intelligence. Nothing new which I'm talking about, you already know about it. But I'm just putting in front of you because tomorrow when you become scientists, you know that, hey, boss, this is human intelligence. And if I'm making machines, what are the differences? What all can machines can achieve and what all can they not achieve? This is very important. Right? Because especially in the context, I'm sorry, Professor Mr. Saket, I may be, digressing from one topic to another. But to give an example, you can make the best autonomous car. But now when that autonomous car is faced with a situation that there is a kid who has come in front of the car, and the kid is so close, right, that, even if you brake, you are going to, dash against the kid and the kid will die. Now, what should you do? Should you just go ahead and dash the kid, or should you veer left and hit against a wall and possibly injure the passenger? So these are certain questions which cannot be hard-coded. These are certain questions which we as human beings are able to do. But whether an autonomous car will be able to do, well, that's an open question for the audience, right? What is artificial intelligence? So we talked about intelligence, ladies and gentlemen, human intelligence or animal intelligence or plant intelligence for that matter. Okay. Now, what is artificial intelligence? So the key word again here, it is that mimic cognitive functions such as learning and problem solving. And some examples which I've given you: human speech understanding, strategic games like chess and Go. Like we have, programs which are able to autonomously drive cars. Or you have programs, which can route intelligently your packets in an internet in a network, or even in logistics or in military simulations. But the key word to my mind is mimic cognitive functions. They're trying to copy our cognitive functions. A lot we have learned from animals and human beings, and that kind of understanding or evolving understanding or evolving algorithms, or that capability to have evolving algorithms or algorithms which are capable of learning from experiences, I have tried to put in a computer program. It's no black magic. It is as if I always say to my students, it's like I'm making a mother of all programs which is controlling so many other things. It's no black magic. Obviously, you know that. I'm just reiterating. Some scientists have even attempted, you all must be knowing about it, that they have attempted to, what is the definition of machine learning? And it's a very common definition which says that there is a task T, right? There is an experience E, and every task has a performance measure, is it not? Okay, I'm trying to make a pot. How circular is it? How beautiful it is? Blah, blah, blah. So there is a performance measure on every task. And here he says that if your performance keeps improving, with your experience. The more the number of times I make a piece of pottery, I'm realizing as a human being, I'm becoming better and better. So if a computer program can do that, then we say that the computer program is capable of machine learning, right? And generally, we talk about three areas of machine learning, that is reinforcement learning, that is supervised learning, and unsupervised learning. And we'll be coming back to these three pillars over and over again. So I will pause here for 30 seconds and I will request the audience to soak in this particular slide because this is very important. We'll talk about it as we go along. Right. So let's come to supervised learning, right? And it's very simple as what you teach your small young brother or your son, right? You keep showing him like if I talk about the classification problem. You show him a cat many times, you show him a dog many times, you show him an elephant many times. So you're hoping that the child is remembering, and a child is automatically able to discern the differences between these different animals which you show. Right. So you keep telling, boss, this is a cat, a dog, an elephant, a lion, a giraffe. You keep telling it to the kid. And voila, next time, after say about 1 month, if you happen to go to a zoo, the kid has learned under supervision. And when he or she sees an animal, the child is able to say that, Daddy, look, this is a giraffe. Because there was so much of training data. Right. Possibly before you took the child into the zoo, you said, okay, fine, let me test my child. We often do that. I show him a picture and ask him, hey, beta, what is this? So your child may say, okay, daddy, this is a giraffe. Most of the times he may be right. Or sometimes if he's wrong, you tell him, no, you made a mistake. This is this. So there is training stage, there is testing stage, and finally there is deployment stage. Right. So this was a simple classification algorithm which I mentioned. Under supervised learning, I can have regression analysis, right? Say, for example, you have the data of 100,000 houses which have been sold in the last 1 month in Pune city. You have the square feet of the house and you have the selling price of the house. So your algorithm is able to make a trend between these two, the one independent parameter and one dependent parameter. But price depends on many parameters: square feet of the house, distance from the railway station, number of bedrooms, number of kitchens, so many other things, size of the garden. Say for 20 parameters. So now how many independent parameters are there? 20 independent parameters and one independent parameter, that is the price of the house. So you give the data of 100,000 houses to this algorithm. That algorithm forms an equation of this hypersurface, and voila, now you throw in a set of parameters or one set of 20 values. This is the square feet, this is the distance from the railway station, these are the number of bedrooms, blah, blah, blah. And voila, it will give you a price, it will suggest you a price. And if you quote that particular price, you will realize that you got a good price also, and your house also got sold quick. You didn't have to wait for a long time just because you quoted very high. So what did I talk on this slide? I talked about supervised learning and two examples in supervised learning, right? Regression analysis and classification. I'm going a little fast because I'm assuming that, people already know about all these things. I'll pause here for about 15 seconds and then we'll go ahead. So this is the example of a classification which I just mentioned. So I have shown lots and lots of apples. I've shown lots and lots of bananas to the machine learning algorithm. And the machine learning algorithm is, after the training, it is now shown an unseen and unlabeled data. And we are hoping that the prediction is correct. So every algorithm has a measure, has an accuracy. Okay. Now I will go to the second pillar, if I would say, or the second area of machine learning, and that is unsupervised learning. In supervised learning, you are giving a lot of training data. You are training the algorithm. You are training the child. Here, you don't have that training stage. And the algorithm. So I was just trying to give an example from social network analysis. So as I was saying, I may have say 1,000 contacts in my LinkedIn profile. So there might be people from defense, people from autonomous industry, people from from the academia, or people from the gardening, or people from anywhere and everywhere. But this algorithm realizes that, boss, these are the 4 areas where he has the maximum number of contacts, right? So this is what there is there is no supervised training as such. An example of unsupervised learning is clustering. Reinforcement learning. Again, a very, very exciting field. Exactly what, Aditya, you might have done as a small child. You were asked to sit on a cycle and you don't have a friend, and you were said, okay, fine. Or you possibly, quietly stole your cycle, stole the cycle of your elder brother. So you had only 2 things at your control: the way Aditya sits on the seat of the bicycle, and how much amount of initial push he gives. And Aditya himself made an aim for himself that, okay, I want to go without falling. I want to go for 3 meters. So he gave a push, and he realized, oh my God, I'm going only till 1 meter. So he said, okay, let me give a little bit more push. Then he realized from 1 meter, I'm going to 1.2 meter. Okay, let me give some more push. Or the way he sits. So sometimes he may go towards his aim, or sometimes he makes a delta change. He may not go towards his aim. He may go away from his aim. So if the delta change is helpful to him, he will continue giving those delta changes. If the delta change is not helpful to him, he will negate the delta change in his sitting position or in the amount of push which he gives. So there is a set of control variables at your disposal: the sitting position and the amount of push and certain outcome you want to achieve. Right? You can control a helicopter automatically using your traditional control system techniques or model predictive control. Nobody stops you. But you can also, create a helicopter which is able to fly in the proper way by using these techniques which I just mentioned, reinforcement learning. So a computer program interacts with a dynamic environment. So the environment is not static. You might have gust of winds, you might have, a situation wherein, there are trees around you and suddenly there's a building in front of you. So irrespective of that dynamism, or you may have another helicopter coming in front of you, irrespective of the dynamic environment, it must attain a certain goal. And what is the goal? That it must be able to fly at a particular speed and in an upright position. And obviously, as I mentioned, the program is continuously avoided of feedback in terms of reward in terms of, are you attaining your goal? And these rewards are tried to be continuously maximized by the algorithm, and hence the algorithm is able to attain its goal. Some example, of course, here it is from classification, right? So you are shown an apple, first you say it's a mango, then you're provided a feedback. No, boss, you're wrong. So you note that feedback. The program notes that feedback and it learns. So next time it is shown an apple, it has learned hopefully, and it will say, no, it's not a mango, it's an apple, right? Deep learning, we all know it is a subset of it has multiple layers. Now, I will not go into what these layers, but please remember, these layers are nothing but computational elements. Nothing so, very esoteric about it or black magic. They are nothing but computational elements. They have a set of inputs, they operate it on a certain manner, and they give an output, and the output can be given to one or multiple other elements in the next layer. And all you are doing, ladies and gentlemen, is trying to change the weights. All these lines which are there, they are nothing but weights. Okay, this blue multiplied by 0.3 here, multiplied by 0.4 here, multiplied by 0.6 here. So all you're doing in your adaptation is trying to modify these weights. That's it. So that for a given set of inputs, you are getting that set of outputs during the training stage. Okay, so I'll not go into details of it, but I just wanted to kind of clear the the smoke from the black magic, so to say. The relationship very quickly between artificial intelligence, machine learning, and deep learning. So I'll pause here for 30 seconds. All the keywords are underlined, ladies and gentlemen, before we go ahead. Right. Let's go into automotive systems, because that was the next part where, as a part of the topic, applications of artificial intelligence in mobility, right? Yeah. So we talked about intelligence, we talked about artificial intelligence, and we now talk about mobility. What are the buzzwords in mobility, ladies and gentlemen? The buzzwords right now in mobility, as we call it in the industry, ACEs. A for autonomy, C for connected vehicles. We are talking about vehicles which are connected to each other, either using their own network or using the fixed network, right? E is electrification, right? And S is shared mobility. There is a thought process which is happening throughout the world, that why should there be a single ownership of automotive vehicles? You know that an automotive vehicle, for 95% of the time, it is just occupying garage space, either in your home or in a society or in your office parking space. 95% of the time, ladies and gentlemen. So why cannot we have a model of shared mobility? Right. Now, this is what, I'm very, very passionate about it, and I request the youngsters, so please start looking at all these models. Right. So mobility includes all those technologies and services that enable people and even goods to move around more freely. Now, this is again, I'm really so excited that you guys are on the cusp of a revolution, and I would say the pandemic has been a game changer. Why do I need to move out? Why can't a package be delivered to me by a drone? Why do I need to go to 10 different shops when sitting in my home? Just to give an analogy, I can go through Amazon or Flipkart or Myntra and do my shopping, right? And move, finally what? Move towards a greener and smarter planet. You all know the amount of chaos we have created because of carbon dioxide emission. So how can we, fulfill our so-called desires also, using a middle path, and also have a greener planet, right? Future mobility is all about striving towards environment-friendly, integrated, automated, and personalized travel on demand. Gone are the days wherein our grandfathers would go and wait at a bus stop for half an hour or 45 minutes and wait for a bus to come or wait for a train to come, right? So on demand is also important. How can we use our time effectively for creating a better world rather than just waiting and wasting our time? Coming to autonomy. I mentioned ACEs, remember? So autonomy, and there you are, ladies and gentlemen. And this is not rocket, this is not fiction, please. All these things are already there in the cars. As Saket mentioned, I was lucky to be there at Jaguar Land Rover in 2017 and 18 for about 15 months. And I'm talking about 2017. All these things were already there. Nothing new. In fact, so many more things. Advanced driver assistance systems. Systems which assist the driver. We all know this. A very, very quick slide for you. I would advise the audience, Mr. Saket, that if they just focus on those 3 areas of machine learning, that itself is more than enough for them to solve a lot of unsolved problems in the area of mobility. It is the the smartness of the students, which will make them understand, hey, whether this problem falls under reinforcement learning, or whether it falls under supervised learning, or whether it falls under unsupervised learning. Those three things should just keep running across your mind. There are so many ADAS systems. I will just look at show you three of them, right? And then we will go ahead. And as I mentioned, Trilochan will handle the latter part of this discussion. It's very important for me, for going ahead, that I should tell you what are the levels of autonomy. And having spoken about that, I'll talk to you what are the 5 pillars. I remember I mentioned to you right in the beginning that if 10 of the students sit together and they say, hey, we want to make an autonomous car. So what all should they consider, right? So that is covered under 5 pillars of AD, and the need for AI in autonomous vehicles. So this one slide covers everything. Okay, let me go one by one. Just follow my audio. So this no automation. Everything is manual, right? And typically, what are the main tasks, ladies and gentlemen, which we perform? We perform steering, that is going left and right. We perform acceleration, going ahead or braking or going behind in the reverse direction, right? These are the main tasks. Now, what is level 1? Level 1, when you can do a single automated function, either left or right or forward and back. We call it longitudinal motion or lateral motion. Lateral is left, right. Longitudinal is braking, accelerating, or reversing. Level 2, wherein you can do both lateral as well as longitudinal. Now, autonomous level 3 is kind of a fully automated vehicle. However, it has got limited capabilities. In the sense, if I'm going from my house in Pune to, say, South Bombay, so up to the expressway, beginning of the expressway at Pune, I will have to drive on my own. But the moment I'm on the expressway, I put it in auto mode. So those 97 kilometers of the expressway, my car will drive in autonomous mode. But the moment I hit the other end of the expressway, again, I'll have to come into manual mode, because the city traffic or the urban traffic will be a challenging environment for my autonomous algorithm. Level 4, it is nearly fully autonomous. However, human override is still an option. I can create an alert, and the driver can, should take over within a certain time. So it has a steering wheel, it has everything. However, fully autonomous, it doesn't have a steering wheel which is visible to you. It doesn't have any of the foot pedals. It doesn't have the gear lever. Nothing is visible to you. Even your grandmother can just sit and go away, right? So this is the level 0 to level 5, ladies and gentlemen. As the slide clearly says, zero human intervention or attention is required, right? I can see a lot of questions floating here, frankly, Mr. Sahay, but I would rather take them in the end, because, only 45 minutes have been given to me, and I don't want to, miss the deadline.
Yes, sir, that would be right.
Yeah.
That would be right. Yes.
Coming back to the 5 pillars of autonomous driving, right? Again, as I said, nothing new. You do it as a driver. There's a lot of data which is coming to you as a human being. You have your eyes, your ears giving you data. Fortunately, your brain does the time synchronization and fuses the data. And then you make sense out of the information. And this information goes to the central computer, that is your brain. Right? So your ears may hear something, but your eyes may see something. But your brain is able to, that what is this you're hearing is from this thing which you are seeing. So it's able to correlate. I have a front radar on my ship. I have a side radar on my ship. Both the radars are seeing the same incoming enemy aircraft. But the common information plot, which is presented to the commanding officer of the ship, shows both those dots as one dot. Means the fusion algorithm is able to say that this dot seen by the front radar and this dot seen by the side radar, they are both corresponding to one enemy aircraft and not two different enemy aircraft. And that is why we use the word common information plot. That is exactly, ladies and gentlemen, what is happening in an autonomous car. You have 7 radars around you. Every radar has a field of view. Your lidar has a field of view. Your camera has a field of view. Your camera is only capturing pictures. Camera cannot, a non-stereoscopic camera cannot give you range with some accuracy. But it can give you the height and the width of the target very nicely. Right? So how you capture all this information, and as I'm repeating again, how it fuses the information and how it perceives the information, that is important. And that is what is sensing and perception, ladies and again, Saket, as I mentioned, no rocket science. If 10 of you sit down together in a room, lock yourself for 10 days, you yourself would have written all these things down, what I'm saying. Localization. Where am I and who or what is around me? Planning. You have a long-term plan. Okay, I want to go from Pune to South Bombay. What is the road which I will take? Whether I will go by the expressway or whether I will go by the old Bombay Pune highway. Right? Short-term planning. Okay, there are these 2-3 cars in front of me. Is there a possibility for me to overtake and go? Hey, I can see the roadside over there. I can see the central divider over there. Is there a possibility for me to, take a sharp left turn? So long-term planning, short-term planning, you exactly do that. And finally, control. But obviously, the control is with respect to some known constraints and capabilities. If you are driving a Tata Nano, which has got limited power, obviously you will not have the guts if you're going on a state highway to overtake another vehicle when you can see that 200 meters from me, there is another vehicle coming in the opposite direction. However, in your Ferrari, if you're in a Ferrari, I can accelerate very quickly and I can quickly overtake and come to the left if you're driving in India. So control also is your actions have to be with keeping knowledge of your capabilities and the constraints. And of course, there is a question of efficiently and effectively. Like if you're in a hybrid car, I often give this example, right? You should know that when should you use the diesel engine, when you should use the electric motor, and when you should use the combination of both so that your consumption is less. Control also requires you to react to a changing situation, which we call it object and event detection and response. Detection of an object, detection of an event, and my response to that detection. Right? Very quickly, a washerman's list of all the sensors which are fitted on a modern day vehicle. So you have external sensors which depend upon emission of electromagnetic signal, sensors which depend upon radiation of acoustic signals, cameras, GPS, connectivity with the mobile phone, right? With your mobile phone or connectivity with the central server and internal sensors. So I'll pause it for about 30 seconds and for the audience to soak up this information. The next slide tells you as to what was the need for artificial intelligence in autonomous vehicle. And you'll be shocked to know that in this 2014 data, 94% of the accidents are attributable to driver error. And the worst part, and this is from USA, believe me, ladies and gentlemen, where the laws against intoxicated driving are very, very stringent, but still these 94% accidents, Saket, were attributable to 31% of them were attributable to intoxicated driving. Very quickly, that if anybody thinks that, hey, I want to understand autonomous driving, so what all he or she needs to understand. In fact, there's a very good course on Coursera from University of Toronto. Okay, I would really, advise the audience in case they want to, understand and they can go through that. Beautifully made course by University of Toronto. I know we have very little time, otherwise I would have talked about each of these boxes. Remember, we talked about motion planning. We talked about data fusion. I know I went very fast. We talked about perception. I'm going back again. And we talked about localization, state estimation and localization. So everything over here is covered. I've gone back, going again. Your sensors which are there, visual perception, and motion planning. I think we are already into about 40 minutes. So I'll quickly just, I will just browse through. I will not even talk anything. Lane departure warning system. It's very clear to you what it talks about. Okay. Adaptive cruise control. Keyword is adaptive. I set a particular speed, but automatically I'm able to change my set speed depending on the motion of the other vehicle in front of me. And overtake assistance. In fact, I was fortunate in my earlier company and in this company to actually work on an overtake assist algorithm, which has got very, a lot of value in our country, wherein we have state highways. We have state highways and we do not have central dividers or anything, right? Okay. I haven't taken a lot of time now. Saket, I wanted to ask you, I hope there is some flexibility for us to speak as far as time is concerned. Okay. So over to Trilochan. He will talk about the next set of slides. So Trilochan, please feel free to share from your slide deck.
All right. I hope my screen is visible now.
Yeah.
Thank you. Thank you so much. So until now, Shishir has just summarized the topics that we have covered. Now I'm going to talk about the applications of AI in electric powertrains. Before going into it, let me give a brief on the architecture of a generic hybrid vehicle, and then I also will give a focus on the components that are included in a typical electric vehicle. So these are the components. As you can see, it is a combination of an IC engine, that's internal combustion engine, which will run on petrol or diesel in India, and also a combination of a electric motor, which will also be used to run the vehicle. Now, the usage of these two can be done independently or as a unit together. Okay. Right. Continuing. Yes, the usage of IC engine or the electric powertrain depends on the requirements of the vehicle. If you need high power, we will opt IC engine. Where in the cases where you need low power or where you are just cruising on a highway, we'll be using a electric powertrain in generic cases. In the scenario where you have to overtake in a highway, then again we will switch to a combination of both, or we will switch completely towards our IC engine operation. Now, the highlighted boxes, as you can see, are the generic components of an electric vehicle, starting from battery until the differential. The flow would be the same, except for the absence of our internal combustion engine, fuel tank, and the generator. So, what are the use cases of artificial intelligence in these vehicles or in these kind of scenarios? Generally, we have three different scenarios to talk about when we talk about the applications of artificial intelligence. One is design, the second is control, and the third is diagnosis. Now, to give you a simple example and to make you understand all the three components, let's take a simple example of a motor design. So, if you have a motor to be designed for an electric vehicle, so the application of artificial intelligence in the design section also important, because the size of the motor, the number of windings inside it, you can see the material used for it, and the testing part during the design, etc. So all the experiences can be fed or can be stored, and the the reinforcement learning algorithm can help a lot in designing an efficient motor in future. And also, when it comes to the control of the motor, for example, if you are controlling your motor with a PID controller, now the values, the constants in the proportional integral and the derivative components might be constant in a normal situation. But if the control is dependent on external variables, for example, in this case of a motor, it depends on the external temperature, it depends on the power requirement, it depends on the amount of power it is receiving from the energy source, that's the battery, and so on. So in these kind of scenarios, we need human thinking like capacity with our control algorithm, which will be able to make decisions based on the all the factors that are affecting the performance of the motor. Now, in such scenarios, we can have our machine learning algorithms in place, which will learn from their experiences in past, and also if there's a training data which will be able to predict which will be able to estimate the required parameters for this particular scenario, they will change the values of all the constants in our PID controller based on the values of the uh, dependent variables. With that, we will be able to achieve efficient performance of the motor as well. Coming to diagnosis, coming back to the same example, the failure of a motor might have various reasons. The temperature might be spiking in times. Probably the speed has been is being affected by other parameters such as sudden braking, sudden acceleration, etc. Now, in these kind of scenarios, we might need an algorithm which will be able to tell us the life of a motor or the possible failures of a motor, and the algorithm might give us a warning beforehand for us to take care of it, right? Or else we might face a failure in our whole system. Now, the examples that I've given are related to a single component of an electric vehicle. And
in fact, Trilochan, I would request you to stop here for hello. Am I audible?
Yes, Shishir, please go ahead.
Yeah, I would in fact request you to stop here for 30 seconds, and I would ask the audience in their own minds, as I keep saying, that they should think in their own minds after the little push.
So I think I've made myself clear with all these three segments of scope of AI in ePartrain. I just want you all to go ahead and read through the slides uh, and try and understand the components in each and every segment. Now, these are only some of the applications. We also have a number of applications when you combine artificial intelligence with both autonomous driving technologies as well as electric vehicle technology. Moving on to the next slide. Now, advantage of automotive industry in India. Some of you might be looking into a career in automotive industry, either based on the new technologies or the prevailing technologies in India. We can see the statistics here clearly. The four main factors why we need or why automotive industry in India is good for a career choice: growing demand, opportunities, rising investment, and policy support. It's clear. I'll just wait for 15 seconds for you to go through. And an update, India has crossed Germany in production of automotive components recently, and is expected to cross Japan as well in the year 2021 and by the end of this year.
In fact, Mr. Saket, how much time do we have more?
So by the timeline, we are done at 11:30. Though I personally am very much keen to know every aspect, and you have thoroughly covered it. You can take, sir, you can take 5 minutes more, then we'll open up for the discussion session if any question audience has.
Right. So yeah. So unfortunately, there was some problem with the network here. I'm so sorry, Mr. Saket. But this is what I wanted to just give myself the wins on. And I would want the audience to realize that how design of a motor is a complicated thing. Gone are the days what we studied in our BTech first year, because here we are talking about a very complicated motor, and it's not only a motor, it is a motor cum generator, right? Because when the concept of regenerative braking, which is now a standard feature in all the locomotives. So whenever the train has to stop, a machine gets coupled with the engine, with the wheels, and that machine acts like a generator, and that electricity which is generated goes and charges the batteries, right? So it's a very complicated design problem, and there your mind will tell you that okay, there are many independent variables, and there is one dependent variables. How is the relationship? So now your mind tells you, okay, yes, this is a problem in supervised learning or trend analysis, right? Like I always keep saying that, because I was in the submarines. So we were always taught when we were youngsters that every battery is like a lady. Her moods are different. And a battery which is new is like a new bride, and a battery which is 4 years old is like a bride who's say 20 years old. So is there a formula by which you can, give to the battery behavior? And battery behavior in terms of what? The estimation of health of the battery, the amount of charge it can store as you go through the charging and discharging cycle. And slowly we as human beings are able, because I was an electrical officer on a submarine, I could sense, if I may use the word, or I could predict the behavior of a battery. But was there a law? Yes, there was some law which the cells in my brain could find out. Can I have an algorithm? Now you will realize what I'm talking about. So this is a problem which we can say is pattern recognition problem, right? So all these 5 or 6 or 7 examples which Trilochan has shown on the screen, you have to think that whether it is a supervised learning problem or an unsupervised learning problem or a reinforcement learning problem. I would like to reiterate, Mr. Saket, at this stage, that a helicopter can be controlled. I know I have talked about it, but I'm repeating. Can be controlled by classical control and model predictive control. Never forget that. But with the computational power which is available with me, can I not control the helicopter by a reinforcement learning algorithm, so that even if it is faced by a situation which it has never been, never we have even dreamt of as a designer, that helicopter is able to fly in an upright position. Very important for you as students, as scientists, to remember this aspect. Where can machine learning be applied and where it should not be, right? That is, sorry, I wanted to reiterate very strongly here once more. The last slide, which Trilochan talked about, right? You can see the upsurge, the future for India. Now, obviously, the next question which will come to the audience, okay, fine, I want to be on the autonomous driving bandwagon. So what should I know? Obviously, you need to know mathematics. You need to be very good at mathematics. You need to be good in Newtonian physics. All your signals and systems which has been taught to you, you have to be good at that, because you have to be good at controls. You have to be good in embedded system design. Thankfully, C-DAC is playing its part very remarkably in churning out good embedded system design engineers. Because finally, your algorithm has to go and reside in a microcontroller, right? And most importantly, which a point, Mr. Saket, which is never reiterated by the by speakers, is that you have to be very good in your communication skills and your teamships, or your camaraderie, your team building skills. You have to start preparing on your written as well as your oral communications, because this is an area where you will be working with people of the world. Now, unfortunately, a Japanese or a German doesn't know Hindi. So you cannot say that, I am very good in mathematics, I'm very good in physics, I'm very good in control system. It's okay if I cannot talk in English. No, it will not work. You have to be a very good oral and a written communicator if you want to do well in life. And that obviously, it starts with practice. You cannot learn swimming by learning the theory of swimming. You have to start swimming. You have to jump into the sea and then start swimming. You have to start speaking the language every single day. Only then you can, learn to speak in good English or speak good in technical terms. Sorry, I got carried away a little bit, which is away from the topic. But over to you, Mr. Saket, and I'll be open to any questions. I think we have how many minutes do we have, Saket?
We'll open for 2-3 minutes. Sir.
Okay, please. Yeah, I'll switch on my video also.
Thank you. First of all, thank you very much. Thank you very much, Shishir Sir and Trilochan. It was thoroughly covered, and personally, I believe I learned a lot from this session, where you started from basics of intelligence and AI, and then how do AI will play the role in mobility, and the basic dynamics of mobility also you have covered, and the career prospects, what could be the future with respect to those who are coming into this field, those who are already into this field. So I thoroughly enjoyed it, and I would feel the same, that all participants would have learned a lot. Thank you very much, sir. It was really privileged for C-DAC Patna to have you as expert speaker. And as you said, our center is also have already, we are in a very new phase. It is only a year that we have started operation, and we have a 5 petaflop AI petaflop supercomputer installed in our premises, and our objectives are the same: to encourage the research and development in these niche areas, and where you could converge HPC AI role of mobility and likewise. Thank you very much, sir. Thank you, Shishir sir.
I'm honored, Sakit, to know that. And I think the parting shot, which I would say, is that and this you can take it coming from a person who was in the services. I would say that every single engineer who is there in the country, and especially the ones who are trained by C-DAC, they are also like a soldier for the country. They should never forget that, because it is finally technology, it is finally the mastery over NLP, finally the mastery over AI, which is going to make or break the future of this country. And quantum computing, obviously we know this. So if C-DAC Patna is providing this particular facility to the youngsters, I think they should just grab it and become experts, right? Whichever field they are, they will definitely be contributing a very, very large part to nation building and to the defense of this country. I think this is one thing which they should never forget. Wherever they are, they are an ambassador. Finally, they have the sticker over here that they are an Indian. That sticker nobody can remove from them. So they are all very important for you. And so glad, Saket, you mentioned about this terrific computing facility which is there. I have visited C-DAC Pune multiple times, and I really have very, very great opinion about C-DAC and the kind of work it does in the Pune center. Thank you so much, Saket, for considering me, and please convey my warm regards to Mr. Sinha. Thanks to him.
Yes, sure. So we will have a 2-minute, 3-minute session. Participants, if you have any questions. Meanwhile, sir, one question was raised during the session from Amit Kumar. He says, how do you see autonomous fighter jet in future relating in AI technology?
See, of course, it's not far away in future, right? But as we say, it is the human intelligence which is the most imaginative, right? I just gave an example from as we say close quarter battle, that you can create a robot which can be a very good shooter, right, Saket? It can have a humanoid form and it can be, but when it goes to a situation that there is a child and there is a terrorist standing, or if there is a terrorist with a gun to the head of a child, okay, whether that robot will have the understanding that, okay, this is a dangerous situation, I should not shoot the terrorist, or whether I should shoot the terrorist or not. So that kind of an understanding, and most importantly, that emotional intelligence, right? All of you have seen the Netflix serial Sheldon. So, you know, he's a very brilliant guy, but people say he doesn't have a lot of good emotional intelligence. So possibly that emotional intelligence will not come there. So we can have good machines, we can have autonomous aircrafts, okay, but still that human element is definitely required somewhere. Any more questions?
Okay. Akshay Khonde has asked if you can share some details of courses related to AI mobility on Coursera or any other platform, if you know, sir.
So as I mentioned, for autonomous driving, there's a very good course by University of Toronto, and if I remember correctly, it's a free course. And as far as artificial intelligence, again, the guru of machine learning is Professor Andrew Ng. So he has very good courses on Coursera. I think these two courses are something which you can start off, and especially Andrew Ng courses are something, you know, which any layperson can start reading and understanding. Yeah, that also reminds me, if you want to get into AI, you should have very good knowledge of linear algebra and probability theory. These are again two areas which are important if you want to, you know, master machine learning.
Any other question, participants? So if you don't have now, you could also send your queries on info@cpettech.in. We'll get back to you.
Okay.
So I would be ending here, sir. Thank you very much. Thank you for the session. And thank you all participants. Take care in this difficult time. We would be meeting tomorrow at same time with another speaker